Now, as I mentioned to you, annuity, listen carefully. Annuity, annuity is when we receive constant amounts or when we pay constant amount, but for a fixed period of time, okay? So I'm going to go outside my slides and explain it to you for you to get it. So for annuity, it is nothing like lump sum. There is nothing like lump sum when it comes to annuities. Annuities is not like lump sum. When it comes to annuities, okay, example of annuity is receiving or paying 1,000 cedis every year. So let's say at the end, let me use at the end. At the end of every year, for next 3 years. So that's annuity. So here it's not lump sum. Well, lump sum, there's one-time payment. Like when you pay it, you allow the thing to roll over. But annuity, you keep paying or you keep receiving every year. Okay. Now, what will be the present value of this amount? What will be the present value? Oh, let's use an interest rate of 10%. Sorry. So the first payment, payment 1. It will be 10,000. So you know present value formula, right? Future value times 1 over 1 plus r raised to the power n. So it will be 10,000 times 1 over 1 plus 10%, okay, raised to the power 1. We're saying 1,000 times, so it's not 10 times, 1,000 times 0.9091. You get 9091. For the second payment, to be 1,000 times. Now remember, the second payment, you get it at the end of the second year. So in the formula, the n becomes 2, okay? The n becomes 2. So 1,000 times 0.8264. So we have 826.4. Then the third payment, 1,000 times 1 over 1 plus 0.10. Remember, the third payment is in the third year. So 1,000 times 0.7513, we get 751.3. Oh, thank you. The first one should be 909.1. Thank you. I think punching mistake. Okay. Now let's add, so all these monies have been converted into a present value. So let's add all of them, because all of them are in present value terms now. All of them are in the same time zone. Okay, so because all of them are now in present value. So everything is now 2486.8. Now the question you must ask ourselves is that, what if the payment is for 30 years? Will we be discounting them one by one? Like you discount year 1, year 2, year 3, year 4, year 5, up to year 30? No. because the payment is regular, the payment for every year for the next 30 years. You can't be doing that. So financial analyst says that you can just use present value of ordinary annuity formula. Present value, this thing is called present value of ordinary annuity. Okay. Now we call it ordinary annuity because ordinarily, okay, ordinarily payments are received at the end of the period, at the end of the period. That's why we call it ordinary annuity at the end of the period. So if it's ordinary annuity, the payment will be at the end of every year. Okay, at the end of each period. Sorry, not every. So at the end of each period. So ordinary annuity means that the annuity payments or receipts are made at the end of each period. So they say that present value of ordinary annuity should be equal to the amount, okay, the amount into brackets 1 minus 1 plus r raised to the power minus n all over r. And again, this factor is called present value interest factor of annuity. This factor is called present value interest factor of annuity. So this question that we solved there, we could have used this formula rather than discounting them one by one. So remember, the amount is 1,000. 1 minus, remember the interest rate was 10%. 10%. So 1 minus into bracket 1 plus 0.10. Then the number of years was what? 3. So raised to the power minus 3. The n was 3. All over r, 0.10. So if you punch whatever is in the bracket correctly, I just finished punching my, I had 2.4869. Some people may be wondering how many decimal places do we leave these factors? Please, the ideal is 4. All right, the ideal is 4 decimal places. Ideal. So when you multiply this by 1,000, you get 2486.9. Like this same answer we had here. This one. You get this? Yeah. So when you are receiving something for the next 30 years, please, you can't discount them one by one. You can't finish. That is why they brought this annuity formula. They brought this formula for you. Okay, that's why this annuity formula came. So you can't be doing them one by one. You will never finish. Now, those of you who want to go with the table, you could have just written present value of ordinary annuity is equal to 1,000, or the amount, sorry, the amount, AMT, the amount, times present value interest factor of annuity, then you do comma, 10%, comma, 3 years. So we just come to our table here. We come to our table. So this is present value interest factor. That's not what we are looking for. You scroll down, the last table in the document I sent to you. We have present value interest factor of what? Annuity. Okay. So we simply look for 10%, 3 years. So 10%, 3 years. They meet here. So you get a 2.4869. 10%, 3 years. 2.4869. So 10%, 3 years. 2.4869. So you write your 1,000. 2.4869. Then you get your final answer. That's all. So you can also read table. Nobody cares about that. You can also read table. So that is the formula for present value of ordinary annuity. Now, yeah. Somebody is saying that I think the table is much faster. Yes, the one you are okay with, you use that one. Now, the question we must also ask ourselves is that if the question said that when you are receiving or paying 1,000 cedis every year for the next 3 years at 10%, what is the future value? Now here also, you could have found the future values one by one, like one by one. You could have said future value is present value in bracket 1 plus r raised to the power n. You do it for the first year, you do it for the second year, you do it for the third year. But then again, it will waste time. So they have brought what we call future value of ordinary annuity formula. And it is the amount into bracket 1 plus r raised to the power n minus 1 all over r. And again, this factor is called future value interest factor of annuity. So the people who want to be reading from the table, this factor is called future value interest factor of annuity. Because most of you joined late, we started at 10:36 or something like that. I think almost 10:40. So when we get to 10:40, we go for our break and then we come back at exactly 11:10. Okay, at exactly 11:10, 30 minutes break. Okay. So that is the future value of ordinary annuity formula, all right? Future value of ordinary annuity formula. And I told you that when you are receiving or paying an amount forever, okay, it is called what? Perpetuity. I told you this. Oh, sorry. You see, annuity has a terminal point. Annuity, you receive or you pay, let's say, 1,000 cedis every year for the next 5 years. But perpetuities do not have a terminal point. They don't. It's forever. Now, when something is forever, obviously, we can't find the future value. It's not possible. Because we don't know when the thing will end. We can't find the future value. Like, it's not possible because it's forever. However, they have devised ways to find the present value. So present value of perpetuity is the amount divided by the interest rate. That's all. Present value of perpetuity is what? The amount divided by the interest rate. That's all. There's no formula for future value of that perpetuity. Okay. So these are the formulas. It's the same thing. Some people will want to do C over R, like the future value one. 1 plus R raised to the power n minus 1. Their C is the amount. So this one is like saying C times 1 plus R raised to the power n minus 1 all over R. It's the same thing. But I like to write it this second way because the second way allows you to easily read it from the table if you want to. Okay, so you can stick to the ones I gave you, all right? And it's the same as the ones in the slides. If you multiply, you get the same thing actually. Okay. Let's take an example. Then when we are done, we will go to annuities, growing annuities. So let's listen. Miss Nancy Boache is planning her daughter's university education. She will enter university in 10 years' time. She will enter university in 10 years' time. And we will need 10,000 per year for 5 years. If the required rate of return on investment is 20%, so if the interest rate is 20%, how much will have to be deposited now in order to make it possible for her to withdraw 10,000 each year at the university? Good. Now let's see. She'll go to university in what? 10 years time. Okay. And when she goes there, she will need 10,000 every year for that, for 5 years. So technically, we are talking about 15 years. From now, like she'll go to university in 10 years time. And when she get there in 10 years time, she will need 10,000 at the end of every year. At the end of every year, she goes to university in 10 years time. So she will need 10,000 at the end of every year for the 5 years. How much must we deposit now? Now remember, when she goes to the university in 10 years time, the 10,000 she will need every year for 5 years. No, that one is an annuity. Okay, so when she gets there in 10 years time, at the end of the 11th year, she will need 10,000, 12th year, 13th year, 14th year, 15th year. Okay, so that part, that's when she gets to the university, that part is an annuity. So let's discount that part. So that part will be an annuity. So we are here, like we are here now. First year, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th. So she'll get to university in 10 years' time here. And when she gets there, at the end of every year, she will need 10,000. So she will need 10,000 here. 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 And she will need 10,000 here. Good. So let's discount the annuity part. When you discount the annuity part, it will be present value of ordinary annuity is equal to the amount into bracket 1 minus 1 plus r raised to the power minus n all over r. So we will have the amount is 10,000. The interest rate per the question was 20%. So 1 minus 1 plus 0.2 raised to the power. It's just for that 5 years. So the 10,000 is just for that 5 years. So raised to the power minus 5 all over 0.2. So my table readers, you can just read present value interest factor 20% 5 years. You can just read 20% 5 years. Present value interest factor 20% 5 years. Oh, sorry. So 20% against 5 years. 2.9906. 2.9906. If you want to, you can punch everything. Everything in the bracket will give you this figure. But me, I read the table. So it is, if you multiply, you get 2990.6. You multiply this by 10,000, right? Yes. Oh, I didn't punch it well. It's 29906 rather, sorry. Now, let's look at something interesting here. Let's look at something very interesting. This money, remember that, and let's listen carefully. What I'm coming to say is confusing, but listen carefully. Whenever you discount, it will bring you to now, okay? To now. So, technically, this 29906 will be at year 11 beginning. Because we got 10,000 at the end of year 11, the end of year 12, the end of year 13, the end of year 14, the end of year 15. So when you discount all these things, it will, the present value or the present time zone, it will bring you to its year 11 beginning. It won't bring you to it now, that's in year 0, no. Because we use 5 years here, 5 years. So it will bring you to the beginning of year 11. But we want to know how much we must deposit now. How much lump sum we must deposit now to allow the person to withdraw the money. So it means that this thing would have brought us to year 11 beginning, or technically year 11 beginning is like year 10 ending. So technically this 29906 is the present value of all these 10,000s as at year 10. But we need to bring this money to now. So the question says, how much lump sum must we pay? So the present value, you use the normal present value to discount because one must know the lump sum that you must pay now for it to grow up to year 10 for us to get the 29906. So it will be 299. So present value will be the future value over 1 plus r raised to the power n. The present value will be 29906 times 1 over 1 plus 0.20 for 10 years. Now, you can just read present value interest factor, not present value interest factor of annuity, not like the present value interest factor for 20% 10 years. If you don't want to read, you can just punch your calculator. So present value interest factor, 20% 10 years. So it's here, 0.1615. $0.1615. The final answer will be 4829.82. That was what is in your slides. 4829 is, if you round it, like 4829 is like 4830, like if you round it. So that's the answer here in your slide. But I intentionally went outside the slide because I want us to know the step-by-step procedure. Okay. So somebody saying I should go over. So the question says that your daughter will go to university in 10 years' time. And when she gets there in that 10 years' time, okay, she'll withdraw 10,000 at the end of every year. Now, the question says that how much must we deposit now? Look at the question. It didn't say how much must we deposit every year. It says how much must we deposit now? So it's asking us how much lump sum payment must we make such that in about 10 years' time, when she gets there, she can withdraw 10,000 for every year. That was what the question was saying. So that 10,000 for every year, when we discounted it, okay, it led us to 29906. Now, remember the 10,000 every year is starting from year 11 to year 15 because when she gets there in the 10th year, when she gets there at the end of year 10, she'll withdraw money from year 11 going. I know some of us will get confused because you think that like normally when somebody is going to school, you give the money to the person at the beginning of the year. It's understandable, but when the question is silent, we assume ordinary annuity at the end of the year. Okay, remember that. When she goes there at the end of the 10th year, at the end of the 11th year, till the end of the 15th year, she has to be withdrawing 10,000. Okay. Now, when you did that 10,000 every year is an annuity. So when you discount that annuity for that 5 years, no, you get what? 29906. Now, when you discount it, that annuity started from the end of year 11 to the end of year 15. So when you discount that annuity for those 5 years, it won't bring you to year 0, never. It would have brought you to the beginning of year 11 because the payments were from year 11 ending to year 15 ending. Once you discount those annuities, it will bring you to year 11 beginning, which is technically like year 10 ending. So the 29906 is the money asset here. But what lump sum payment must we make now for us to get this one in about 10 years' time? So the question was asking us that this 29906 is a future value as at year 10. And how much present value must we make now? So present value will be equal to 29906 divided by 1 plus r raised to the power n, which is what we've done here. And we had this. Because a lump sum payment. The person was asking me, is it clear now? The person who says, can you go over again? If it's not still clear, I will mute you, then you ask me where you are getting confused. Okay, you are okay. Okay, the person says sure. Okay. Okay, good. So the same question again, but the question now says, what if she doesn't make a lump sum payment, but she makes what? A yearly contribution towards the goal. What if she makes a yearly contribution towards the goal? That's now the question. What if she makes a yearly contribution towards the goal? Now remember that she needs to make payment to get 29906 at year 10 ending. So if it is lump sum, she pays 4829.82 now. What if, the question is asking, what if it is a yearly payment? Instead of lump sum. So remember, we want to make a yearly payment to get this future value. So it means that we are looking at a certain future value of what? Annuity. Once you have to make a yearly payment to get a certain future value, okay, make a yearly payment to get, it's not a lump sum. Once you need to make a certain yearly payment to get a certain future value, we are dealing with future value of annuity. So the payment we don't know. And then the formula is 1 plus r raised to the power n minus 1 all over r. So we now have 29906 is equal to the payment we don't know, into bracket 1 plus 0.2 raised to the power 10 years, okay, yearly payment. So 10 years minus 1 all over 0.2. Remember, this thing is the future value interest factor of annuity. So instead of punching calculator, you can go and read future value interest factor of annuity, 20%, 10 years. Future value interest factor of annuity, 20%, 10 years. So I'm going to read. That's the second table, future value factor of annuity, 20%, 10 years. So that's 25.959. 25.959. 25.959. 25.959. Oh. 25.959. So if you make the payment the subject, it means that we are dividing both sides. So we will have, so here over 25.959, here over 25.959. So that's the answer here. Okay. So that's the answer there. This question is actually a past question. Like it's a past question. I think it was for about 10 marks or so. It's a past question. Somebody saying thank God. Why thank God? Either it's difficult or why thank God? It's not very difficult too. When you go, I'm sure when you sit down, when you go over the video and things, you understand. So if this is a past question, it simply means we must be expecting similar things, like similar. Okay, that is the implication. Your question will not be, yeah, somebody says you need to understand. Yeah, that's the point. It's not difficult. Just when you have to sit down, go over and you understand it. It's not anything difficult. Okay. So we'll go for a break. When we come back, we will deal with growing annuities, all right? Growing annuities. Okay, so let's try and get something good to eat because today we'll travel far a little. So we'll go for a break now and we'll come back with growing annuities. So what will happen is that I will stay on, as in I'll leave the link on. Okay, so we come back exactly at 11:10, 30 minutes time, 11:10. Or let's say 11:13 because it's now 10:43, so 11:13. So I'll leave my link on. If you want, you can leave and join again with the same link later. I don't have a problem. Okay. Because of maybe your data. I will leave mine on and then we come back. So please, exactly 11:13, I'm starting. So when you are not on, I will not wait for you. Exactly that time I'll start. And this course, when you come late, all that we are doing going for you may not understand. So please let's come in. All right, so we will continue at that time later then.